We have George, and he has a 4-inch vortex meter, which is pretty typical of what we sell here at Tactical Voltmeters.
So this is a vortex meter. This vortex meter could be used to measure steam, gases of any kind, and liquids. It is particularly suited for steam and gases. For liquids, we like the mag meter for that because the accuracy is a little better. But this one is what you use when the temperatures are high, and the way that it operates is I'm going to pull. Let's see if I can lift this over so that I can show you what it looks like on the inside, so that makes sense.
You've got the mast. What did Dave call that?
This is a bluff body.
The bluff body. That thing right there is the bluff body, and that creates a vortex.
That creates a vortex, and the vortex, the vortex frequency is based on the geometry of that bluff body, and it's also based on the velocity of the flow.
And the piezo chip is. Ooh,
Yeah.
and there's the back side of it. You can see that it's a triangle.
Yeah, that little blade in the back is an oscillator, and attached to that oscillator is a piezoelectric crystal, and piezoelectric crystals.
You can just see it there, the piezoelectric crystal.
And those are sensitive to stress. So when you stress a piezoelectric crystal, let's say through regular oscillation, you're going to have a voltage, and that voltage relates to the flow rate. So the nice thing with this one is you could have any kind of gas, let's say a mixture, like let's say it's some kind of a biogas. We have methane and CO2, and the concentration does not matter. The only thing that matters with this meter is the velocity of the fluid, whether it be a liquid or a gas, and it measures the same based on absolute velocity. And what we do is we have a pressure sensor, which is right here, and we have a temperature sensor right in the neck. So what we do is we use the temperature and pressure to determine density, and from the density and the velocity multiplied across the flow area, we could determine mass flow.
Cool. So what are some pretty common applications where you would use this?
Yeah, saturated steam is a very common thing. Like people that are interested in making a food product, they'll use steam for their processes. Also, power generation. This would be measuring the steam that is used to cause the generator to spin. That's a very common application. For gases, you could use pretty much any kind of gas, pretty much at any flow. And the reason I say that is because this meter is only sensitive to actual flow velocity, not to be confused with standardized flow velocity. So if you have a very high pressure application, high pressure applications usually relate to high mass flow. A high mass flow will require a high pressure. So no matter what kind of flow rate you have, this thing will always be able to keep up with it because the very high pressures that are needed for the high mass flows pretty much lower the actual velocity of the meter. And that's what this meter is sensitive. This size meter only requires 4.9 feet per second velocity for it to trigger. That's very low, and it could go all the way to about 400 feet per second.
Perfect. So once we buy it, in terms of calibration, is there anything we need to do? Do we plug it in? Do we call you? How do we, once we buy it and it shows up, what do we do?
Yeah, all you do is you install it, turn it on, hook it up to the power. Typically, we'll sell it as a 24-volt DC. You'll just attach your power connections, and then you'll if you need to attach your 4 to 20 milliamp or your Modbus RTU communication.
And if I have any troubles, do I phone Taiwan? Do I phone Hong Kong? Is there anybody that'll help me?
Yeah, you're gonna get the very best help available. Dave Corpy, who is my boss and the main guy here at our company, he's the person that you'll reach on the phone, and he'll literally tell you how to do this, and he's the guy that designed it all. So you're in great hands.
So any questions? They're going to be answered ASAP. It sounds like.
Yeah.
Perfect. And